Hello everyone, this is a video lecture for Calculus 2, section 10.1, parametric equations. What does parametric even mean? So basically we have an t independent variable. And normally, variable, there you go. Normally we have x is an independent variable and then y is my dependent. Well, now I have t as my independent variable, and you plug it in to both x and y functions. So these are dependent now, both of them. The main thing that we're going to be doing is just trying to solve for something that's more coherent, rearrange it, I guess you could say eliminate the parameter. But besides that, we also want to graph things, and it's important to note that the direction is now important. So let's just say I had a parabola like this. Back in the day, we would just put two arrows and say, oh, it's going up on both sides. And yeah, that's fine, but in parametric, t is time, and so we want to know what's going on as time continues to go positively. And so we would have to put some kind of arrows to indicate as time keeps going more and more, what direction is it actually going. So little arrows like that are important, and we're going to be talking about those as well as we keep going. So let's do some problems. I got 10, 1, 0, 0, 9. So x is equal to t cubed minus 3, and then I've got y is equal to t plus 2, and they're saying go from negative 3 to 3 for your t. So we want to graph it, and then what they say is eliminate the parameter, which is basically make it look something more rectangular, something that we're used to. What I'm going to do is I'm going to go a little bit more backwards than what you might expect. I want to simplify this thing. I don't even know what this thing looks like without using some kind of graphing calculator or something. So how do I know what it's going to look like without using that? Let's simplify this down. I'm going to actually minus 2 on both sides here and say that t is equal to y minus 2. This is a pretty easy statement, and notice that t, I can actually plug it in directly here. So now I got x is equal to y minus 2 cubed minus 3. This is actually the answer for part B. They say eliminate the parameter, and there you go. You can see that I don't have any t's. That is, the parameter t has been eliminated. It's gone. Now you might be thinking, well, I can't really understand this. Well, hold on. I messed up one thing. It's supposed to be a square there. Regardless, cube square. Sorry, I'm looking at my notes here. This is actually a square, but same math. It hasn't really changed. And so I want to graph this, and you might be looking at that and saying, hey, I don't know what the heck that looks like. It's kind of weird looking. It's backwards. Yeah, basically, if you were to say y equals x minus 2 squared minus 3, what you would have instead here is a parabola. It's pretty basic. You would say, oh, it's a parabola shifted over and down, and so we'd have a parabola kind of like that. That's not my point here, though, because what we have is this guy, and it's not exactly the same. What you could do is take this and kind of change their axes and graph it a different way, but really what this is going to end up being is a sideways parabola. My y is going to be shifted inside opposites up 2. So this is my y, this is my x. I'm going to go up 2, and then my x is going to be shifted back 3, and then I have a parabola, just something like that. Of course, now I want to know what direction it's going to be going, and it's actually going to be going this direction here like this. Now, why is that? The reasoning being is that if you keep on plugging in more t's, like a higher t value into these guys, especially this one, say you got a t equals 100, that's a pretty big one, you're going to get a y value that's positive, that's big. So the more t, the more y. It's just going to get higher and higher as you keep going. Okay, sorry I messed up on the square cube thing, but the math was about the same. Of course, the graph would have been a little different. 10, 1, 0, 1, 1. So I have got x is equal to the square root of t, and I've got y is equal to 6 minus t, and they say eliminate the parameter and graph it and all that stuff. This one's pretty easy to solve on this side, but I would rather do this instead. What if I square both sides and I get this? And I can plug it in. So y is equal to 6 minus x squared. And that's your answer to part B. Again, eliminate the parameter. But now this is actually pretty easy to graph. You can see it's a parabola upside down that's shifted up 6. So 1, 2, 3, 4, 5, 6. And then we got our normal parabola. But you can see that I messed up one thing there. See the arrows? they can't be going in both directions, not in parametric land. There I go again. I want to know where the arrow is going to end up being in the end here. And so what I like to do is say, let's plug in t values here and really big ones, like 100. Well, notice that I'll get like a negative 100 or negative 94 or something like that. So it's definitely going down over time, but both sides would be going down over time. So that didn't help. Rather, let's plug it in here. If I plug in a 100, notice that I'm going to get the square root of 100 is 10. So I'm going to get a positive 10. My x values are getting more positive as I keep going. So yes, I'm going down, but I'm also going to the right as I keep going down. And so that's going to be the direction in this particular case. What you could also do, if you're a little bit confused, is make a table. Not exactly like that, because what you're going to want to do is t values here. And so you start with t equals 0. Plug it in and see what you get. It would be a 0 and a 6. Plug in t equals 1. So you got a 1 here, and then you got a 5. And then plug in t equals 2, et cetera, as you keep going down. You'll kind of map, as you connect the dots, where the arrows are going. Okay, you can just follow the line exactly there. Let's do another one. We got 10.1.015. And so x is equal to sine of 1/2 theta. And I've got y is equal to cosine of 1/2 theta. And they're saying go from negative pi to pi. Okay. So what am I supposed to do with this guy? How can I solve for one and plug it into the other and all that? Well, there's a trick, a cheat, I would almost say. Whenever you see x equals sine, y equals cosine, or x equals cosine and y equals sine, some kind of format like that, what you're going to get is a circle. That's a circle right there. Well, that's a circle. So it's a circle that looks kind of like this. And what we have to do more specifically is figure out where it's going to start and end. So notice that it says negative pi to pi. That's not necessarily being exactly where I need to go. I have to kind of understand what this means is, more specifically anyways. If I plug in a pi, negative pi or pi into these guys, what I'm actually going to get is a pi over 2. Notice that I'm going to have a pi, half of that is pi over 2. So what we're really going to end up doing is going from negative 90 to a positive 90, and that's going to be, I guess I can do that kind of notation, I don't know. So I'm going from a negative 90 to a positive 90. And I know you were thinking, oh, negative 90 to positive 90, something like that. Well, hold on. So we're not doing cosine and sine like that. We're doing sine and cosine in this particular format. When x is equal to sine and y is equal to cosine, you're starting actually up here, like north kind of thing. It's like a bearing. And generally, when you have it like this, it also goes clockwise, generally. We'll be talking more about that on another problem. But this is the format for starting up here, and then we're going to go down that way. The thing is, though, is that we're not starting at 0. We're starting at negative 90. Again, after the 180, we plug it in, we're going to get a 90. So we're starting at negative 90, which should actually be over here. Then we go up to 0, and then we go to positive 90 over here. So the actual graph looks something like that. Okay. Again, this is not perfect or anything. You could just make a table every time. It would just kind of take a while. Just different ways to do it. I'm trying to show you the faster methods, I guess you can say. Recognition. So I got x is equal to sine t, and I've got y is equal to cosecant t, and they say go from 0 to pi over 2. Okay, so how do I approach this problem? I think the best way, at least right now, is going to be using this. I'm going to say that t is equal to the arc sine of x. And so all I did was move the sign over, make it an arc sine, that kind of thing. But now I can plug it in directly here, and so I've got y is equal to the cosecant of the arc sine of x. Now, technically, this is a eliminate the parameter and we're done, but really, does this help you? Does this tell you what the graph is? No. So what we could do is instead say that's 1 over sine. And it just so happens that sine and arc sine cancel, leaving just a 1 over x. So my answer, my eliminate parameter graph thing is 1 over x. So the graph of 1 over x looks something kind of like this, but I'm wanting to know more specifically what we're talking about. If you go back up and notice, it says from 0 to pi over 2. And so if I plug in a 0 for my t right here, sine of 0 is 0. Whenever I plug a pi over 2 in, I get sine of pi over 2 is a 1. And so my x value goes from basically 0 to 1, and that would be it. Notice that would be 0 to 1 or something like that. So my actual answer is going to be something kind of like this, and it probably will just stop. There you go. There's some arrows for you as well. More technically, if you're inclined to technicalness, it really actually doesn't have an equal sign right there. That was my own mistake. It doesn't have one here, but that's not really the point there. This one didn't have an equal sign. What it's indicating is that you can't actually equal 0, and that makes sense when you do the math and everything like that, because the graph here, you plug in a 0 there, 1 over 0 is infinity, and you can't actually have that for just a graph here. I guess you could say it's undefined. Okay, 10, 1, 0, 1, 7. So I've got x is equal to t cubed. I've got y is equal to ln t, and they want to eliminate parameter and graph it. I think the easier way right now is going to do this guy. T is equal to the cube root of x. And so I'm going to take that and plug it in right here. So y is equal to ln of the cube root of x, and you're done. If you want to go a step further, you could say that that's a 1/3 power, bring it out to the front, and you would then have 1/3 ln x. There you go. How do you graph ln of x? It looks something kind of like this. So there's your graph. The way WebAssign actually has it is x is equal to e to the 3y. That also works, but they better take that as well. If they don't, you tell me, and I'll start getting upset at somebody. It will be okay. It will work, I think. So 10, whoa, I don't know what's going on there. Let's back up there. Okay, 10, 1, 0, 3, 4. So I don't even have anything for this one besides my little note here. It says match the graph. And if you want to use Desmos here, it's probably best for the homework. Exams, you would make a table. So you're matching graphs together. It's a match it kind of problem. When I was saying Desmos, I meant desmos.com. And you go to the graphing calculator and you can put in some parametric stuff. I don't know, I can't remember exactly how to do it. I'm not going to show it here, but there is a way to use this tool, and it's easy to use. Now, that's not really allowed on the exams. I don't really say that we should be doing this all the time, but it's okay to do this on occasion because it's just a tool, just a graphing calculator, and we're learning tools as we go. Don't use it as a crutch, just use it as a tool, and occasionally use it, again, knowing that on exams, we're not thinking that way, okay? So that's just a kind of reminder. There are options to kind of, I don't know, do some of the homework problems or even a quiz problem like that. Okay, I got x squared plus y minus 1 squared is equal to 16, and it says change the parameter. Now they got, here, let me actually graph what they have. They have a graph with this guy. So it's a circle, if you haven't noticed, but it's been shifted a little bit. It's been shifted up by 1, and so this is technically the center, and that's my radius, and it goes out. I know I didn't make it look very good, but it's supposed to be shifted up by 1. This point P right here is supposed to be at 4, comma 1, because again, my radius is a 4, and so on and so forth. I think up here, this guy's going to be a 0, 5, which we'll be using here in just a minute anyways. Okay, so we've got a circle. It's been shifted a little bit. Cool. Well, part A says we want to go around the circle once, and we want to do it clockwise. Let me just write clockwise. And we're starting at the 4, 1 point, and so we should be going 0 to 2 pi for my t. Now, going around once, 0 to 2 pi, is completely normal. Those are basically saying the same thing right there. Clockwise is a little different, and starting here at the 4, 1 is interesting. Notice that we had that previous problem where I started up here, went down, and that was when x was equal to sine, y was equal to cosine, and we went clockwise, right? So that's what I start thinking whenever I see that. Problem is that I'm not starting up here, I'm starting right there. Let me show you with Canute color. I'm actually starting here. That's my point where I'm starting. So I'm starting at the point as if x is equal to cosine and y is equal to sine. I guess you could say like your typical one. But this here goes counterclockwise generally. But I want to go clockwise. So that's kind of weird. It's like mixed. What do I do, you know? Well, we're going to stick with this format, but what I'm going to do instead of starting here and going around this way, I want to go this way, and so I'm going to have a negative somehow changing that direction. And in particular, instead of going positive y, I'm going to go negative y. And so therefore my y value will have a negative in the front. So let me show you what the answer is. X is equal to 4 cosine t. Make that a little bit better. Still didn't make it better. Okay. And then y is equal to 4 sine t, and then plus 1. This is your answer with the comma and everything like that. Just type it all in exactly. Technically over here, there's a plus 0, and that kind of helps us understand that these guys right here are what is shifting. So I shifted it to the side by 0, but up 1. Okay, so we got that much. The 4 is my radius. Of course, all I'm doing is saying x is equal to r cosine theta, y is equal to r sine theta, that kind of stuff. But essentially, I'm just adding an x naught, y naught, an initial center, I guess you can say. So this is familiar to us. I'm just adding a tiny little bit there. And I need to put a minus sign right here in front of y to be able to make it go down instead of up. See how negative will make it go down? And so this right here, that little negative sign, changes it to a clockwise orientation. Okay. So if that's a little weird, I know, let me do part B and part C. It's kind of the same style. So we got 2 rotations, both counterclockwise, and again going from 0 to 4 pi. Well, this is easy. 2 times 0 to 4 pi makes complete sense. They're saying counterclockwise, and I think we're starting at the same point. And so we're doing this, and we're doing one more time. So 0 to 4 pi makes complete sense. We're going counterclockwise, so everything's fine. What I'm saying is this should be a plain old format formula. Just here you go, 0, and then my sine plus the 1. Like that's it, you're done. There's nothing else to talk about. This is our basic format, no negatives, just x equals cosine, y equals sine. We've seen that since pre-calculus. And then finally, it says we're going halfway now, counterclockwise, and we're going to start at the 0, 5. So we're starting at the top. Here, let's shift it, I guess. There we go, 0, 5. We're starting at the top, and we're going counterclockwise, which is going to be this way. Kind of weird yet again, I'm mixing up my stuff here. To be able to start up the top, though, I would say that we're going to use the x equals sine and the y equals cosine format, this kind of style here. That's going to definitely get us started there. But this right here alone makes it go clockwise, which is not what I'm wanting. I want counterclockwise. So I want to go, this is normal, but that's not what I want. I want to go this way. So how do I do that? I'm going to make one of these negative again. And notice that my y is going to be going down in both cases, so it's not going to change anything. But my x is getting more negative as I go this way when I start out. So I'm going to put a negative sign on this guy right here. And so my final answer is going to be x equals negative 4 sine of t, again plus 0 I guess, it doesn't really matter, and then my 4 cosine of t plus the 1, that is my final answer. And that's all I got. So thank you very much, and have a great day.